Okay, so our next lesson in topic 3 that you guys are going to learn is about translation. So we've already talked about rotations or reflections, sorry. That's where we flip something, just literally like how the mirror that you look in flips your reflection. A translation is kind of like where you just slide something. So that definition that's at the top of your notes is a translation is a transformation in a plane that maps all points of a pre-image. Let's review. Pre-image is where we start, the figure we start with. We're going to slide it in the same distance and in the same direction to create our image. So you can think of a translation as like a slide. Left, right, up, down, based on our X and Y values. And it is also a rigid motion. The size and the shape doesn't change, just literally the location. So we're going to start with our first example, and it says find the image of triangle EFG under the translation, and you're going to see this little less than and greater than symbol that we're used to seeing, but they are kind of in place of where we're familiar with parentheses. Those are called vectors. You don't really have to know that, but it'll come up one day in physics. And that essentially tells you in the X coordinate, we're going to move 7. And in the Y coordinate, we're going to move -4, which is going to mean down 4. And so this rule that's at the end of your packet about translations is you're going to see it as AB, and this is going to take our XY of where we start, and we're going to, for our X coordinate, we're going to add the A. So the first number is how the X coordinate changes. And then for the Y coordinate, we're going to add the B. That's how our Y coordinate changes. So in this example of 7, -4, let's put that into words first before we do our first real example. With 7 being the X and X being left and right motion on a graph, a +7 means we're going to go right 7. And then a -4, with it being in the place of the Y coordinate, Y is our up and down movement on a graph. If that's a -4, it means we're going to go down 4. I don't need to close that parentheses. That's not a parentheses. And so we are going to do that literally with each point to start. So I'm going to start with E. And to find E prime, that's what we called the image. The prime notation represents once you've moved it. We're literally going to count right 7 and down 4. So I'm going to count out loud for this first one. I go right 1, 2, 3, 4, 5, 6, 7. I go down 4, 1, 2, 3, 4. And this is going to be my E prime. And we're going to do that with every single point. Luckily, this is a triangle, so I only do 2 more. Let's go to F. 1, 2, 3, 4, 5, 6, 7. Down 1, 2, 3, 4. And there's F prime. Last one, G. 1, 2, 3, 4, 5, 6, 7. Down 1, 2, 3, 4. G prime. Now we can draw that triangle. And there is my translation. We slid it right and down. And that's all translations are going to be. We're going to move it left, right, up, down. So let's practice looking at a figure that's already had a translation. I can see in this I have STUV and I have S prime, T prime, U prime, B prime, aka I have my pre-image and then I have my image. And I can see the coordinates of these. So I went ahead and you can pause it, write out the coordinates of STUV of your pre-image. And now let's find the coordinates of our image, and we are going to actually write the rule of what happened. So S prime, I'm going to keep that in orange because that's what color this is at -6, +2. T prime is at 2, 1. U prime is at 2, -6. And V prime is at -5, what is that? -3. And so we just have to figure out, was our x value added or subtracted, like did it move left or right? So you can kind of look, I've got s here, and I'm going to go to the right and then down to get to s prime. So it looks like for the x, we go from -5 to -6. That is only, and when I said right, I definitely meant left. We're only going to the left one. So for that, in our translation, for the x shift, every single one of them is only going left once. So we would write that, since we went left, as -1. That x shift is -1. And then for the y shift, it goes down. I'm going to erase this. I always like to just look at my first point. So I've got s to s prime. We go left 1 and we go down 1, 2, 3. Let's see if that makes sense. For s prime, oh, maybe we go down 4. I should zoom in and be really sure, because this is at 6 and s prime is at 2. So we definitely go down 1, 2, 3, 4. Yes, it'd help if I would zoom in. 6 down to 2, we went down 4, so I'd write that as -4. And this notation of capital T with our vector, you could call it brackets or parentheses, vectors, of -1, -4 means literally go left 1, down 4. And I could look at the rest of these on the graph to check my work. But that's pretty much all you're going to be doing with translations, you guys, is going left or right. So this video is about to be a lot shorter. We're going to do one example down here where they give us our pre-image and our image coordinates, and we are just going to write the rule. So we just want to figure out how many, does it go left or right, or in this case, like what's the x shift, what's the y shift. So I'm going to zoom in on this now. I can see that r starts at an x value of 1, and then it goes to an x value of -5. So if I'm going from +1 to -5, I'm subtracting 6. And we could check from 1 to -5, from 3 to -3, from 4 to -2, taking away 6. Let's check the y. 4 to 0, looks like you take away 4. 5 to 1, take away 4. 4 to 0, take away 4. 2 to -2, take away 4. So that translation is -6, -4. So you're going to pause. You're going to try the last one on this. Pause it. Try it. 3, 2, 1. You should have paused it. If you haven't paused it, stop. Pause it. Now check it. That should have been a translation of -2, -4. So now you're ready to do your translation practice. You got